Swayam Prabha. Digital India. Educated India.
Hello everyone. In our last session, we are discussing that the key points in the standards, particularly NIJ standards for testing the body armors. So, we discussed the back face signature, and for measuring the back face signature we need the backing material, special backing material are required. So, now we will discuss the backing material. So, there will be a special material, it is typically clay material. The main characteristics will be that after deformation it will be completely viscous, it will not actually have any elastic recovery. So, that is the basic characteristics requirement. This is actually it is a placed at the back of the specimen. So, this is the specimen and bullet line here, and at the back of the specimen it is kept, and which helps in the back face signature measurement by indenting. Okay, indentation will be there. So, the deflection will be there. So, the backing material is placed on a box like rigid frame with removable backing. So, here it is on a rigid box, we have there will be rigid box, this is the box here, and in the box we fill with the backing material. Okay. So, the removable backing material they used for the perforation BFS testing, but it does not test the ballistic limit, that is important. Here what we test the BFS testing, backface signature testing, but not the ballistic limit test, because ballistic limit test where we need this velocity to have complete penetration. We here complete penetration is not tested. Here we by the back face signature we try to assess the trauma which will be generated due to the bullet hit. That is main idea of back face signature testing. Now, for any test we need pre-test observations. So, that these are basically one is the workmanship examination. So, for any test the suppose on garment we are testing, on body armor we are trying to test, there should be actually complete. So, there should not be any defect in that. So, all armor samples are inspected before testing. Okay. It should be properly stitched. So, everything the size would be should be as per the standard. There should not be any flaws there, or it should not be damaged. So, any deficiencies are documented with the photographs. If any damaged armor if we want to test, that should be actually properly documented. So, you suppose we want to test any armor with some flaws, before testing we should identify and document this. Suppose deliberately we want to test any damaged armor. So, for that we have to document it. So, conditioning will be there. Okay. Samples must be stored at least 24 hours under ambient condition, and flexible vests and jackets are subjected to conditioning protocol to simulate wear and tear. So, before testing, as I have already mentioned, that NIJ that 10106 standard, there we have to simulate the wear and tear condition, particularly for flexible vest and jackets. So, submersible before perforation and back face signature test, few flexible vest, jackets or hard armor sometime or plates inserts, they are submerged into the water for 30 minutes to simulate the actual condition, and they are then dried for 10 minutes before being mounted for testing. So, first you have to dip into water, submerge into water, and then we have to dry before any testing. Conditioned flexible vest and jackets are tested in dry condition. So, we have to dry it. So, backing materials and armor mounting. So, the backing preparation is there, you can see. So, this is actually plastically deformable, it is not elastic. So, it should be plastically deforming clay. So, after removal of the load, there should not be any recovery. This is important. So, the clay will be there to capture and measure the back face signature. So, this is important. The clay is manipulated to create smooth. So, here if we put in a, this is a frame, on the frame we are putting clay. So, these are the clay material, and clay we are actually manipulating to make it a smooth surface. There should not be any indentation, prior indentation should not be there. So, flat surface free from any void, there should not be any void. So, this is actually to ensure the consistent measurement of depression depth. Suppose for after one heat we have measured the back face signature. First heat, this is the, and here is the surface, and above that our test specimen is there. This is a test specimen armor. Now, when the back face signature, when the bullet is hit, so there is a back face signature. But after test we must remove it, the frame, and then again manipulate it to make it smooth, flat surface. So, this has to be repeated after each shot. The clay has to be manipulated to create smooth flat surface without any void. Okay. If it is not done, then this deflection, whatever back face signature we will get for the next test, it may be wrong. So, every test, before every test, after every test we have to take out this frame to measure the back face signature, and then we have to label it properly before we take the second hit. And these are the process of backing material mounting. Okay. And next will be the armor mounting. Now, we have to mount the armor properly. So, this is our suppose body armor. This armor has to be mounted properly, and so that it does not move, and it is kept in a particular position for the bullet shot. So, armor mounting is done with the armor panel is placed on the backing material and secured with the mounting straps. So, armor panel will be there, and where it will be placed on the backing material, and there will be particular strap. This it will be mounting strap will be there, so that the armor does not move. There is a special guidelines are there. The default method where 2 vertical, if nothing is specified, there will be 2 vertical strap, okay, and 3 horizontal elastic straps are there. So, this is the backing material fixture, and here on that we are on the fixture we are putting the this our armor panel. This is the armor panel is there, and this will be fixed by the elastic strap, 2 vertical and 3 horizontal. Okay. But some armor may use integral straps, some special strapping is there. Now, this is for standard strapping for smaller sample, this is for smaller sample, but our frame is there, fixed frame is there, but for large sample we have to extend the frame. We can see here 2 vertical 3 horizontal straps are there, and backing material fixtures were there earlier, but here extension of the fixture. You can see this is the extension of the fixture shall be coplanar with the front face of the backing material. So, this fixture has to be extended for larger sample, but backing material is the same here, backing fixture is there, but for larger sample we are putting some additional extension of the fixture. Now, this is a special strapping method. So, special strapping arrangement sometime we use. Okay. So, special strap arrangement where the strapping is special strapping is required. So, we have to now reposition after each shot. When we shot the some first hit, then after each shot we have to reposition. After each shot, armor panel is manipulated by hand to smooth out the deformation. So, any deformation is there, armor panel is manipulated by hand. So, the panel is then repositioned on the backing material for the next impact, So, and so that the next impact will not occur over the BFS indentation, which is supported by smooth clay. So, that is there. So, we have to manipulate it and smoothen it by hand. Now, PBFS, which is perforation and backface signature test. So, this is a back. Now we have to do test. We have created the backing material, we have placed our body armor in a fixture. Now, we have to test it. Now, you can see the bullet hit or a particular place on the backing material, on the armor we have to hit. So, this is the say body armor, and here if you see, this is the acceptable zone, because we have to we cannot hit at the center. So, at the edge, near the edge we have to hit. Out of 6 hits, so 3 hits are at the near the edge, that is acceptable zone, and 3 hits are near the. So, 1, 2, 3 are at the near the edge, then 4, 5, 6 at the near the center, which is the circle defines the maximum spread of the shot. So, here these 3 hits are there, and this is the circle. So, maximum spread is there. If the hits are in on other places, so these are the hits. So, then circle would be like this. And then if the there we have already 6 hits are there, no additional short zone. So, these are the no additional short zones are there, additional shots are not required. The short locations, you can see the short locations are clearly marked on the armor panel. So, armor panel we are clearly marking the short locations, and for a flexible vest and jackets 6 shots are fired on the specified pattern, in a specified pattern, and with the 3 shots near the edges. So, near the edges we have to have 3 shots at least, and 3 clustered together in a circle. But this 4, 5, 6 it should not be very close, that is already mentioned. There has to be certain difference, that a particular distance specified. So, in general armor panel the impact locations are, this is shots 1, 2, 3 shall meet the shot to edge, that is called the shot to edge distance. Okay. 2 terms are there, one is shot to edge distance requirement, but they shall not be located more than minimum shot to edge distance of 19 millimeter. Okay. So, they should not be located more than the minimum shot to edge 19 millimeter from the edge of the panel. So, this panel edge is here and this should not be more than the this 19 millimeter, which is called short to edge distance. And next one is that it is a short to short distance. So, 4, 5, 6 are basically meet the short to short distance requirement, but all 3 shots shall be located within 100 millimeter diameter of circle. That is very important. This distance should be, that is the short to short distance, there is certain requirement, say 5 millimeter, 5 centimeter requirement. But this location here, if we form a circle, that circle should be within 100 millimeter diameter, maximum it should be 100 millimeter. So, what we are trying to see, the effect of edge and effect of the body. So, short to edge specifies the at the edge what is the performance, and the short to short distance what is the in the body area what is the performance. So, this all requirements should be there. Now, testing procedure, perforation and backface signature test, fair heat requirements as we have mentioned. So, a shot is considered fair heat if meets the specified criteria, which are the angle of incidence, it should not be more than plus minus 5 degree from the intended angle, like if it is intended angle is 90 degree. So, it should not be more than plus minus 5 degree. The short to edge and short to short distance are met, that means distance that we have already mentioned, and another is the velocity. Velocity is within 9.1 meter per second of the reference velocity, plus minus 9.1. So, there are different reference velocity and it should be within plus minus 9.1 meter per second, that speed. So, speed should not be more than say plus minus 330 feet per second. It should be within the short to short and short to edge distance and the incidence, angle of incidence. Then if it is there, then this the short parameter will be considered in the next stage. So, first is this whether we are the heat is to be considered or not or rejected. So, that is actually assessed in the by fair heat. Then next is that test duration. So, basically from the first shot, after first shot what we do, we take the backing material, make it labeling, we again by hand we try to manipulate by hand the this frame, that ballistic vest frame we try to manipulate, and after that we do the second heat and it should be fair heat. Like that we repeat the heat, like say 6 heats we do, but all these tests should be carried within 30 minutes time. that is also there, from first shot to last shot. So, we cannot wait for long time, because the armor may get affected with the changing humidity, changing temperature, or many other conditions, or maybe the UV ray if we are doing from in the outside. So, there may be any effect. So, to eliminate all these chances, so we have to test, we have to perform the test within 30 minutes from the first shot to last shot. So, then perforation and back face signature checking will be there. So, after each fair hit, so this is important, after each fair hit the panel is inspected for perforation and the back face signature depression depth is measured. Now, BFS back face signature is measured, it is a depth is measured using device with an accuracy of 1 millimeter or maybe lower. The back face signature is recorded, and if it exceeds 40 millimeter, then second measurement is required. Suppose the back face signature is suddenly it is going high. So, if it is more than 40 millimeter, we have to check, recheck the thing. It is due to the actual body armor, or maybe there is something wrong with the leveling of the backing material, or maybe gripping, placing the body armor. So, there may be some doubt. So, we have to test if it exceeds 40 millimeter. So, and perforation requirement is that this is back face signature, and perforation requirement, the armor must withstand the required number of fair hit without any perforation, okay. And the back face signature depth measured should not exceed 44 millimeter. So, ballistic limit determination. So, how to test the ballistic limit? The test setup is all shot are tested at 0 degree incidence, that is exactly vertical. So, that is here 0 degree incidence, and all samples are tested in dry condition. So, it is done using the military standard, US military standard. So, test follows procedure from MIL standard 662F, okay, US military standards, where we test the term which is a V50 ballistic limit test with the specific parameters for velocity steps, different parameters we use for measuring the V50. V50 actually refers that the speed, the velocity of the bullet, where we the chances of perforation penetration is 50%, that is called ballistic limit. The number of shots and samples required for a complete ballistics test is actually it is given in the standard. So, what will be the number of shots required to test the ballistic limit? So, the data reporting, all shots which are fired for this test are reported. So, it is not that some shots are all the fair shots are reported, including the shot number, desired velocity and actual velocity and the outcome. So, all shots. So, we try to test with at different velocities. So, what is the desired velocity is required and what is the actual velocity is coming and what is outcome, whether it has penetrated through or not penetrated, everything should be recorded with it. So, this and we have to take the all fire. So, performance requirement for new armors, no perforation should occur at or below maximum perforation back face signature fair hit velocity. So, at particular minimum velocity there should not be any perforation. Okay. And the estimated probability of complete perforation at PBFS reference, that reference velocity must be less than 5%. Okay. So, that is the performance requirement. Next is the NIJ 10801. This test is basically for ballistic resistant protective materials, not the armor, body armor. It is a protective material that we have already mentioned earlier. The key points here, this standard establishes minimum performance requirement and test method for ballistic resistant protective materials, and it was published in September 1985, and then it is actually changed, and at present NIJ 108 standard is used. It is specifically designed for materials used in fixture structure, fixed structure, basically any structural fixture we can use there, and any equipment like in maybe in or that is in vehicle, okay, that bulletproof vehicle, it is not used for body armor or helmets. And the standards are basically adds to new threat level 3A and makes threat classification which is as per the NIJ standard, other NIJ standard. So, the standard is applicable wide range of materials, including metal, ceramic, okay, transparent glazing, bulletproof glass, fabric reinforced plastics, any composite material. So, all these materials we can use which are not used for the body armor. These materials actually are used to create items. After this testing, these materials are used for different places like portable ballistic shield, protection for fixed structures, the guard stations, control rooms, for those materials we use, armor, vehicle armor we use. So, here again the classifications are here we can see that 1 level 1 is added here, 1, 2A, 2, 3A, 3 and 4. This is was not there in earlier standard, which is for ballistic body armor. And special type classes are also available for a particular customized threat. So, the key test requirements here again the workmanship is there, like in body armor also. So, materials must be free from defects like dents, cracks, okay, sharp corners. So, that we have to check. Labeling must be perfect, that is the each material must permanently and legibly labeled, clearly labeled with the manufacturer's information, material type, month and year of manufacture, and certification of compliance with the standard. So, everything has to be labeled then before testing. So, we must know all the information, and the ballistic resistance test specimen must be able to prevent the bullet from perforating a witness plate placed behind the material here. Here actually in place of back face signature, that backing material we use the witness plate, because it to prevent the perforation of the. So, that is if it perforates the witness plate which is placed behind the material, that means the ballistic resistance is not as per the standard. Now, let us see the testing, how the testing is done. The sample, the test specimen must be at least this size. So, 12 inch by 12 inch, 1 feet by 1 feet size will be there, and there is no such stringent requirement like body armor. We have to keep the material in normal room temperature 20 to 28 degree, within that range for 24 hours, and test setup, the specimen is positioned 5 meter from the muzzle of the test. So, the test weapon it should be away from it is at 5 meter distance. A thin aluminum witness plate is placed like 6 inch behind the specimen to detect the perforation. So, this is the witness plate is thin aluminum foil plate is thin foil. So, which is positioned at 6 inch or around 15 centimeter behind the specimen, and here fair heat conditions are almost same. Heat is considered fair if it impacts at angle within plus minus 5 degree from the vertical orientation, and also at least 5 centimeter distance between the two shots. So, then we will consider it as fair heat. So, the ammunition and perforation requirements, the standard defines specific ammunition and velocities for each level. So, there will be like body armor, here also different types of ammunitions required, handgun threads. So, handgun threads are here for 1, 2A, 2, 3A. So, it is a lower level of threads. These are tested with various handgun rounds like 22 LR 9 millimeter 0.44 magnum. So, 0.44 magnum. So, all these different types of handguns are used for the lower level of threads up to 3A, and the higher threads which is rifle threads for level 3 is tested with 5 shots of 7.62 millimeter full metal jacket round. So, that is the specified type of threads that rifle. So, this is required, and level 4 which is more severe. So, armor penetration rifle. So, tested with a single shot of 0.3006 AP armor penetration ammunition. So, here level 3 we need 5 shots, and level 4 we need single shot test. The test must achieve the specified number of hits without any penetration of witness plate. If the witness plate there is a penetration, then the specimen will be that it is a failed specimen, that is not as per the standard. Now, this is the basic test setup, test range, where we can see from the test weapon, this is the test and this is the test specimen. Total distance as per the standard should be 5 meter, and there will be 2 chronograph. This is one and second chronograph. These chronographs are actually used for measuring the velocity within the distance of 1 meter. So, here velocity is measured, the time between this chronograph the time lag is detected, and from this time lag we can measure the velocity of the bullet. So, if we see here, now the weapon is here, the firearm or test barrel is used here. Now, this is a chronograph, the measure the velocity of the bullet, and here is the test specimen, and the material is being tested is held in a support fixture. This is a support fixture is there, this is the material. Now, here if you see the just below the behind the test specimen, so 6 inch typically 15 centimeter behind that we put one thin aluminum plate, and that is a witness plate. If there is any penetration through this test specimen, in case of body armor we use the backing material, back face signature was measured, but here we use the witness plate to detect any penetration. So, the witness plate is a thin aluminum sheet which is placed behind the specimen. So, any penetration in the witness plate is actually indicated by passage of light through the hole of this plate. So, the penetration, any small penetration, if it is not visible in the naked eye, so then we can actually test it against the light. So, any light penetration which will indicate that there is a hole formation. So, this distances, the distances between the weapon and the specimen varies depending on the threat level, and normally this here it is in as the standard, a normal standard it is a 5 centimeter. If the threat level is high, that can be varied. Now, here you can see the for lower threat 2A, 2, 3A, even 1, the distance is kept 5 centimeter here. This is the 5 centimeter. But for higher threat like 2, 3, 4, the distance is kept 12 meter. So, the two distances are actually arranged for different threats, because for higher threat if we keep the 5 meter, then obviously this there will be clear penetration, that in that case it is not possible. For higher threat we keep the distance higher. Now, apart from this NIJ standard, there is another standard, so NATO standard is there. So, if we see that as per the NATO standard, NATO AP 55. So, this is actually standard is the protection level for occupants of logistics and light armed vehicle. So, for a light armed vehicle we have some protection level. So, we should know the from the what are the different types of threats. So, from rifle threats, the protection level here it is 1 to 5, 1, 2, 3, 4, 5 level. So, 1 being the lowest level of protection and 5 is the highest level of protection. For rifle, different types of bullets are specified here, and here the distance is 30 meter is kept, and the different velocities are kept. So, 833 meter per second for M80 and 900 meter per second it is SS 109. So, different speeds are there. Similarly, infantry rifle, here the because their distance are kept longer to make it actually the real type situation, where the firing will be at approximately within that range. That is why because this is for logistics and light armed vehicle, and for infantry rifle level 2, which is again from 30 meter, and the infantry rifle is specified bullet is that is specified here, standard bullet, and the speed is here 695 meter per second typical. And then level 3 is for sniper rifle, where this the bullets are specified and 30 meter distance, and here speed is 930 meter and 854 meter per second. And for type 4 it is for heavy machine gun, and here distance is specified at 200 meter. So, for heavy machine gun which is firing in a logistics or light armor vehicle, for that 200 meters are distance is specified with a 911 meter per second speed velocity of the bullet, and for 5 which is very high level of protection. So, for this type of vehicle, light armor vehicle, okay, there the cannon attack may be there, automatic cannon is the type of threats where the type of bullets are specified. Here distance is 500 meter and the speed here is little bit higher, 1258 meter per second. So, these are the as per the standard of by the NATO standard. So, what we have seen earlier, that is the those are the different standards for ballistic protective material or maybe ballistic body armor. So, now what we will be starting how the different textile materials can be developed for our ballistic protective performance. So, textile based composites are used, it is not normal fabric we cannot use, because we should use the multi-layer composite materials. So, this is basically it gives the lightweight material for ballistic protection. So, the composite structures we can these are of different types of composite structures we can make. So, the basic definition here is the material is formed by combining two or more constituent material here. So, if when we are having more than two or more constituent material, then we will call it as composite material. Here you can see this this panel here with the some matrix, there is a fibers reinforcement is there, this is composite material with significantly different properties. So, two materials will have significantly different properties, like matrix will have different properties and the fiber will have different properties. Fiber will act as a reinforcing material, and where one is the textile material. So, this is the textile material fiber, it may be fiber or may be fabric, and other will be a matrix material, that may be any polymer. So, this two if we when it is mixed, and that will actually produce one material which is known as composite material with a entirely different characteristics, very high strength and modulus. So, the total characteristics will change, that is called composite material. So, key textile fibers which are used for ballistic protection are basically aramid fibers are widely used, like Kevlar by DuPont and Twaron by Teijing. So, these are widely used for ballistic protection, the aramid fibers. These are used basically for their high strength and good thermal stability. These fibers they have very high strength and good thermal stability. Apart from this, that high molecular weight, ultra molecular weight polyethylene are also used, like Dyneema Spectra, because of their extremely high strength to weight ratio and excellent energy absorption. This is these two fibers are two types of fibers are widely used in the ballistic protection, but the ultra high molecular weight polyethylene main problem is that it is the melting point is low, but it is but still it is used. Apart from this, the basalt and glass fibers are used. So, they are used in hybrid system for structural integrity and cost effectiveness. The roles of matrix are polymer resin, epoxy or phenolic resin we use in the matrix, which binds the fiber and transfer the load and provide environmental protection. So, the fibers are actually are protected, and also this they transfer the load from one fiber to another fiber. Basically, this fibers are used for the as a reinforcing material, and we can use the elastometric matrices, epoxy and phenolic matrices. They are actually not the thermoplast thermoset, they become very solid and they are not flexible. But if we see if we use the elastometric matrices, that can enhance the energy absorption and also their delamination will be reduced. Apart from this, we can use the nanomaterials, nanofibers we can use or nanoparticles we can use in the matrix, which will improve the matrix property and also fiber matrix adhesion. So, fiber matrix adhesion is very important parameter for the improving the matrix characteristics. So, ballistic resistance mechanism of textile composites, this is very important. So, if we have a composite material, so what we have seen earlier, the how the this impact at different stages of impact that we have for a hard body armor that we have discussed earlier, but here we are going to discuss the ballistic resistance mechanism of textile composites, and I think that we will discuss in the next session. Till then, thank you.